In this walkthrough, we're going to be examining and exploring an Ext4 file system for the purposes of chasing down a particular image file that's been used to help illustrate some key points in this lecture. For this walkthrough, we're going to be using two separate tools, the Sleuth Kit within the Windows PowerShell environment and Xways Forensics. So let's first take a look at our file system using the Sleuth Kit to get some basic file system information. We're going to be using MMLS. Well, first we have to change our directory. If you notice that we're in C Windows 32, let's go ahead and change our directory with a CD space. Here we go. To help move things along, I'm using tab to help pre-fill in some information if the tool can figure it out. And now we're in our directory. We can ls here, and we're going to be working on the ext4 training.001. So we're going to use mmls ext4 training.001. From here we can see our starting offset position will be 2048, and there's only one partition that contains user data located within this particular storage drive. So we're going to here use an fsstat -O for offset 2048, and then ext4.001 to get us a listing. Now we can see here with this particular file system that we have a lot of groups that are organized here. This isn't a very large file system to begin with. It's only about 300 megabytes, but you can see here, even with 300 megabytes, we still end up with a lot of different groups. The file system in its design will break up the blocks that it's assigned to manage. You know, think of sectors, the blocks that it's assigned to manage into different chunks, and it organizes those chunks into structures called groups. Now that we have our file system statistics already printed out, we can always refer back to that by scrolling up or redirect that to a text file for further analysis. Let's continue on. Again, we're chasing down img_6009.jpg to kind of see where this particular file is and get this information about this particular file. So let's go ahead and hit up on our keyboard, and we're going to take a look here for FLS. And we can see that we have a little bit of information here, but we might not see all of it. So let's go ahead here and add in a -R switch to, or option, to be able to get all of the information in here. Now we can see right in our particular screen that the particular file we're chasing looks like it might be tucked within a directory, because we see this plus sign, which indicates that it is a subordinate of a particular directory. Whereas we can see two plus signs mean it's in a directory, and that directory is within another directory. So we can see here that our inode number of 32426 is the inode associated with img_6009. Let's take a look at the particular details of 32426 and find out what we can learn about img_6009.jpg. We can see here that it is allocated. It does not have a marking indicating that it is represented or it's deleted. So we should be able to successfully recover this particular file. So 32426 is our particular file we're going to chase down. So we can use our let's make it a little bit easier. Hit up on our keyboard. From here, we're going to just take out all that previous information, type in istat space, and then from here, space again, 32426, and then hit enter. Wait for it to finish. Scroll up just a little bit. These are all the blocks that are associated with this particular file. And here we can see the top half of our inode information. Just one key characteristic to note before we continue much further is that directory entries within the ext4 file system contain the file name. An inode does not contain the file name. Once the system locates the particular inode, basically discards the file name and goes with the inode. The file name is more or less just for user comfort and convenience. The file system doesn't really care about the file name. It cares about the inode. if we wanted to take a look at this particular directory entry associated with img_6009, we can actually go and locate this using the tool Xways. A little bit easier, in my opinion, than locating it within the tool, the SleuthKit. Now, SleuthKit does a fantastic job with sorting out a whole bunch of details for you. But when it comes to directory entry, it might be a little bit easier to take a look at it in a different tool. User preference. So we're looking here in our first partition. We go to space, looking at 6009. Then we could go to navigate. Then we can go to seek parent object. And from here, if we open this up just a little bit more, we also have our data interpreter open. If you don't have that open, you can go to view and go to show and then select data interpreter to get that to pop up. And scrolling down here just a little bit, we can see that directory entries are present. Kind of like a cooking show, some of this has already been done for our time efficiency, but at the very beginning of this directory, which is located right here, you can see the very consistent, similar pattern present. We can see here that this 4-byte sweep here is 32,426. How did I figure this particular location out? I didn't invent it. I reviewed the publicly accessible documentation for the Ext4 file system, which is located in this lecture, to find my way through this sea of information. Once I found it, swept for 4 bytes, and that gives us where the first inode is, or the inode associated with this particular file. So again, directory entries largely contain the inode where more information about the file and the blocks that it's associated with are located, as well as the file name itself. The inode contains a lot more other information, such as information consistent with like the attributes in an NTFS file system, timestamps, all the blocks or data associated with that file, user permissions, ownership rights, and other relevant information that makes accessing a file possible. So far, using these two tools, we've been able to locate the directory entry and the associated inode number for the image file img6009.jpeg. We've also taken a look at the metadata associated with this file using the istack command in the SleuthKit. So let's take a look at actually getting this file out. Now there's two different ways using two different tools. You can do it by hand, or you can use a little bit of automated assist. In the istack command output, we saw that there was a significant amount of blocks associated with this file, which would make manual recovery of this file, while possible, very time consuming and very easy to create a small but fatal error. So we're going to use a little bit of automation to help us with this work, but just know that you could, if you had to, do this completely by hand. Now using the SleuthKit, using Xways, we could just select right-click copy and go to desktop, and we could just put the file right there. And if we refresh our screen, the picture shows up. Just showing you the differences in tools here. Using Xways, it automatically pulled the metadata that was originally associated with this file into this recovered file. So that way, it's all mirroring what it was in the file system. Not all tools are really as easily capable of doing that, or they're not set up to be able to do that as easily. So using the istack command, we could take a look here. We can see that the same information exists with this particular recovered file right here. We can see that it has some information associated with it being created or actually access modified on 5/17, and it was created today on 6/20/2020. Now if we use a tool called TSK Recover. TSK Recover is a tool within the SleuthKit that's used to pull out allocated or unallocated or both types of files from a particular forensic image. So we can use TSK Recover and then we can force it to just pull out allocated because we know from our previous FLS analysis earlier in this walkthrough that this file is not marked for deletion. It's not marked as unallocated. We just want to get it out. So we're going to use a -A switch, and then O for specifying our offset, Ext4. That's our file. Then you have to hit space on your keyboard and you have to specify a path where you're going to put it. So in this case, I'm just going to keep things a little bit organized and create a quick directory called output because I want to put it somewhere particular. Now, from here, you can just type in where you want it to go, and it will go wherever you push it, as long as you have permissions to do so. And then just take that last backslash off by default if you use the tab option. If you type it out by hand, don't include the backslash. Hitting enter on your keyboard will indicate that whatever the process results were. In this instance, we have files recovered 43. If we go ahead and double check and open that up, we can see the directory structure is here. It's very similar. We have space docs, and garage is allocated. Again, remember we use the allocated command to just pull out allocated files. Here we can look at some images, and we can see here that properties show a different picture using the sleuth kit. So it's just important to know how your tool operates and handles. In this case, we have the picture, which is great. We have an accurate file name, also great. But we have here tarnished metadata relating to file creation timestamps. This is very different than what we saw when we looked at the iStat report, but that's just how the tool is recovered the information. It's just went in and it has just pulled out the pictures itself. In this instance, we lost some of this information, and this could be really important. You know, this is only 3 days, but 3 days could make a worldwide difference depending on what you're doing with this particular file. If you just need to get the file out, this is an acceptable operation. But we can see here that with Xways, we got all that information perfectly fine. It did the job of pulling out that particular data. That all matches, and it's all correct, and it's all consistent. So we can see that we have a little bit of differences here between these tools. Both tools do the job, but slightly different ways. We just have to be careful. So this is a good way to use multiple tools and be careful and confident on how these tools in particular operate when you do certain actions. In this case, both tools were used to pull out a file, and they presented or associated this file with a little bit different information. So that was just chasing a particular file using the sleuth kit and Xways for the Ext4 file system.